Hi guys, today we are presenting the MYWAI Equipment as a Service platform, and we will go through the introduction of what product servitization is and how is it affecting the manufacturing and original equipment manufacturers market. We will then deep dive into the MYWAI Equipment as a Service suite, and last but not least we will present three key projects that MYWAI is developing internationally. The first one, the RAISE project for Mitsubishi Electric, within European Commission initiative for Trinity Robotics. The second for EaaS, a European leading producer of medtech equipment, ultrasounds and MRI machinery. And last but not least, the satisfaction project for a leading container and reefer logistics manager, developing the solution for tracking and monitoring reefer and containers around the world in planetary supply chain for food, beverage and other goods. Well, first of all, about product servitization. So product servitization has been a key dream for producers and manufacturers since the beginning, to the point that Mr. Ford was actually thinking that a business absolutely devoted to service would have only had the problem to count its revenues and profits. And so he didn't actually want to sell the Model T one-off on a capex basis, but wanted to rent it or subscribe it, have it subscribed by users, getting new pieces of the machine or gadgets or chassis and other parts on a continuous basis, renewing their product on an ongoing basis. Now, we all know that eventually wasn't the, let's say, the feasible in those early stages of manufacturing, but today it's more and more becoming very, very relevant, to the point that we are calling a new service economy coming to place, both for equipment and for infrastructures which host and include those machineries and equipments, to the extent that they can start offering very good services from the post-sales deploy, delivery and supply of the goods, from their ongoing maintenance and uptime monitoring, down to the final disposal of the bits and pieces of the equipment in a future-proof green economy circular usage of such materials. Obviously, there's been tentative goals to servitization even in the past, the most famous being very successful, like Xerox, which did it in the early 80s, moving its sales model of printing machines from buying to renting and then to pay-per-use and pay-per-outcome. Actually, the copies produced on an hourly or daily basis by companies renting the machine, but also Rolls-Royce, which in the 90s did a very profitable business of selling its engines, aircraft engines, not as a one-off sale, but as a recurring model by hourly fly hours. This, to be achieved, obviously requires a very important digital transformation of the manufacturing business, where initially the revenues will go down because you're actually passing from a one-off capex sales to a recurring OPEX model, and the cost for doing that in terms of infrastructure and also of platforms can be very costly. But if you start buying off-the-shelf solutions like MYWAI, and you also use expertise like the MYWAI engineering to deploy it, presumably the cost will go very quickly down and the revenues go up again, giving light to this fish chart, which is quite famous in the area of equipment servitization. Today, this is something done by major manufacturers, from very big ones like the Heller Group in Germany, which is doing lathe machines, and which is now sold on a prepaid card on an hourly basis, down to smaller equipments like the FlexVelop air compressor, which is sold not one-off, but on the basis of cubic meters of compressed air. Obviously, all this market has had a key acceleration during pandemics because plant and equipment owners couldn't afford actually to have them stopped and unused and to pay them very costly upfront. And so the idea of having a solution which would monitor the critical uptime of medical machinery could enable their regulation from a distance, respecting social distancing, and last but not least, protecting the privacy and security at the edge of all the information retained by the machinery became not only important but vital. Essentially because during pandemics you had to have live actionable information coming from the field which you couldn't access. And if you think about it, having actionable information coming through smart analytics and smart data is the same thing that you need also in factories and equipments in smart cities or enertech or other sorts of industrial applications. This is actually something which is getting also very popular on the consumer basis. This is these are charts from Salesforce CRM Leader, which on a yearly basis studies the servitization trend, and they report that more than 80% of manufacturers are going towards servitization, but also surprisingly, nearly 70% of consumers would prefer to rent or to pay per use of a washing machine or a car or whatever else in order not to pay upfront, but to have an ongoing service base which gets the product better and better and continuously maintained and upgraded. Now, which are the services that the users are ready to buy are essentially the simpler ones, so location-based detection of where the equipment is and how much it's used, and also the maintenance part, which is obviously very important, where we have more or less the two leading services today sold on equipment as a service model. But in the next future, we expect other killer services like the prognostic maintenance, or with additional intelligence on the lifetime of a product, but also insurtech and fintech companies starting to support pay-per-use of the machinery or pay-per-actual outcome produced by the machinery, or if you are an insurance group, extending the warranty or giving parametric insurance to cover not only the product itself, but also the production which is engaged in the use of the equipment itself. As I said, the killer application main one today is the maintenance part, because there's a long history of big companies adopting predictive and prognostic maintenance, but it was actually limited to the 5–10% of very critical, mission critical equipments and plants which could afford the costly sensors and infrastructures. Today, with the big lowering in price of sensors and platforms like MYWAI, you can actually think of commoditizing prognostic maintenance for everybody and for anybody, and not only starting detecting the anomaly of the detection of anomalies or the failure which is about to happen, or the remaining useful life of your product and process, but also the right time to maintain, which more than a technical variable is actually when is the right time in terms of production, finance, and even market conditions to go and maintain the machine or its parts. Once that you know that maybe it's going to break in a week or a month time, you can actually decide which is the right time algorithmically to go and do the delivery. And this is where ERPs and CRMs will kick in to give intelligence on top of the equipments. Obviously, this is a key topic for operational intelligence in factory and industrial manufacturing, where the information management is moving up the ladder of infrastructure from field-based machine-to-machine communication, which is quite effectively managed today in Industry 4, up beyond the firewall into ERP, CRM, but also edge intelligent platforms and equipment as a service and operational intelligence platforms like MYWAI. To do this, there's been a lot of initiatives around the world, even to standardize the interoperability of machinery, like the Industry 4 initiative in Germany or others around Europe, which have actually standardized the way that you can actually talk to machines, both at the very low communication layer, where a standard like OPC-UA has been established to secure and encode and transmit information from one machine to the other machine. But interestingly enough, OPC-UA is also a consensus standardization body, which is starting to move up the ladder of structured information, developing standards for semantic interoperability of the machinery, developing semantic machine twins. And this has been quite brought forward in Middle Europe, in Germany, above all, where the VDW, which is the Machine Tool Association, one of the largest in the world, and VDMA, Europe's largest professional association, that of the mechanical engineering sector in Germany, have actually teamed together and under UMATI, Universal Machine Technology Interface Consortium, are helping OPC-UA to develop a lot of companion specs dedicated to more than 30-40 specific machinery, so that the third-party service providers for maintenance, for insurance, for fintech, for legal tech want to provide services, they don't need to do it one-to-one for each vendor, but they can do it on the basis of an interoperable, open, semantic twin specification for machinery. And this is something that in MYWAI we are fully embracing, being a UMATI active partner, both in the development of new specs and in the adoption inside the MYWAI EaaS platform. Now, describe these trends about product servitization. Let's see how the MYWAI Equipment as a Service suite serves them at best. Well, first of all, the platform is an edge intelligence platform. It's mostly focused on the edge intelligence operations that you need to do to study the signal and to actually dispatch algos, intelligent algos at the edge. So the full funnel from raw signal capture to the labeling of such patterns inside such signals, if you are on a supervised model, so that you have subject matter experts creating teams, defining labels of patterns and getting consensus amongst the players inside and stakeholders inside the organization. Or if you're doing it in an unsupervised fashion, asking the algorithms to automatically detect clusters of normal functioning patterns and detecting anomalies simply because they are different from what has been learned from machine learning being the normal functionality of the equipment. At that point kicks in the full algorithm generation, from pre-processing to transformation to actual artificial neural networks implementation, down to the dispatching on the edge or the fog, which can happen in software using Dockers, containerized software, or can happen in hardware or hybrid like FPGA, which is a field programmable gate array, which is a piece of chip which can actually be flashed with logics, or the ASIC chips, which are application-specific integrated circuits where specific architectural networks, artificial neural networks can be implemented in parallel with optimized microcircuitry to be very low consumption and very high power. And at the end, if everything works, the full pipeline needs to be tested, validated, and stored, even legally, in the case you have any compliance issues or legal tech claims about the failures and the malfunctioning of your equipment. So MYWAI does this both for the time series and for the multimodal, multivariational analysis of these data. So not only many sensors giving time-dependent information like pressure, temperature, or others, but also imagery like a visual inspection of pieces, video analysis, 3D model analysis, and so on. This is actually done end-to-end, so we get all the stream of information from the edge, we transmit it to the fog and to the cloud, we actually store it with appropriate databases, being either blob storage or time series storage or NoSQL, SQL data storage for structured or unstructured data. And finally, everything is analyzed with the pipeline that I was saying before, and eventually dispatching the algos directly on the field, either with SCADA and interfaces or directly with actuators. And finally, if you have a pre-existing plant with a lot of pre-existing sensors and SCADA dashboards and so on, we have a layer named MAGIC, which is Machine Gateway for Information and Communication Interoperability, where we also access historian data on the back end, and we interface with events and alarms infrastructures using standards like OPC, SCADA and standards, or MQTT also for channeling and passing information to the cloud. Now, as a consequence, the platform is quite full of modules, so it's a quite extended suite. First of all, you have the first layer, which is the analyzer, the edge analyzer, which is actually buffering the information on the edge that you need to have for not only getting the information, but having it processed into the algorithmical layer of the platform. Then you have the cloud part, which is fully fledged in terms of all the storage of the information, all the pipeline buildup and approval, workflow, and orchestration of delivery and dispatching of the algos. And then you have a dashboarding of all the machinery in terms of uptime, running, executing executable algos, and all the events and alarms which are recorded. Last but not least, is a very interesting backend based on new generation distributed ledger technology, which brings blockchain far beyond the original implementations. It's based on IOTA DLT, which is not a blockchain, it's actually a mesh for swarm intelligence edge computing units, which are able to give timestamping and storage of anomalies and failures, so that third-party service providers can actually do service tech or even insurance or legal tech claims based on neutral certified data. And the MYWAI DLT is also coming with smart contracts and non-fungible tokens for the unique identification of machinery and their subparts. The cloud part is quite what you would expect from a cloud implementation. It's got all the dashboarding, all the location, all the machinery with uptime, and a fully configurable multi-tenant, multi-user and roles configuration for the platform itself. The edge part is one of the most sophisticated modules. It's actually enabled you also to have a very flexible hardware integration, possibly for implementing different levels of artificial neural networks. As I said, both on the fog or on the cloud, but also at the very edge, either using deep learning models with accelerators, or shallow learning and smart data, which is demonstrated having the same effectiveness of deep learning and a much more wider trustworthiness and explainability of the data. For doing this specific shallow part, we have also developed a unique board, which is the neural board that you see there on the lower right side. It's a proprietary system on module hosting more than 5,900 neurons for classification using radial-based function. And it's very effective if you want to have very low power, massive classification of anomalies. Alternatively, you can use industrial raspberries up to industrial PCs that we provide, or if you already have everything in place, you can use Dockerized software for delivering those algos. The board is quite unique. It's produced directly by MYWAI and its partners, and it uses an M2 slot for going inside existing edge computers like the EaaS, the Adventex, the SECO, and many others. It implements a fully parallel architecture for streaming anomaly vectors, or actually information vectors coming from the field, and triggering a winner takes it all if the distance from the anomaly pattern is a minimum. So just to cut the technicality short, it's very low power, very low cost, and it's got a massive parallel consuming capability for classifying not only time series, but also imagery and video coming from industrial production belts for visual inspection, or to alerting systems of time series coming from smart cities equipments, or industrial equipments, or medical equipments choice. Last but not least, the DLT is very innovative, not only because it certifies everything which happens, but also is coupling a swarm filing system like the interplanetary file system IPFS with the IOTA DLT, so that you can also store anomalies and videos or images of failures or time series of failures while certifying with NFTs exactly which piece of the equipment or which equipment went failing. And smart contracts are under implementation for insurance and finance service providers which want to have secured and unique certification of the piece of equipment to be managed and serviced. So this brings us quickly to the free projects that we want to just quickly introduce and then invite you to actually our website or to our exhibition spaces to actually see them in place. The first one is the RAISE project. The RAISE project is a project which has been done for the Trinity Robotics initiative under the European Commission, which is also partnered by CECIMO, the European Association of Machine Tool Vendors, and engages also some insurtech startup like YOLO or artificial neural network hardware artificial neural network expert companies like the Lithuanian Neurotechnologies. These companies are actually developing with MYWAI a fully fledged end-to-end solution for managing robots as an intelligent service ecosystem, where we are embracing the OPC robotics interoperability spec endorsed by the UMATI consortium that we are working together to import inside our platform and to enable third-party servicing either for maintenance or for insurance or pay-per-use of the physical object. And we are also studying its extension towards the metaverse, where in the future we foresee smart factories available on a production metaverse, where you will be renting equipment and assembling them in a cyber-physical factory using cyber-physical assets. The other project that we are actually developing is the Promenade project, which is another very interesting project done for the European and world-leading producer of ultrasound machinery and magnetic resonance imagery, MRI solutions, which is EaaS, together with a set of partners, Sword, Innovina, ZENATEK, and Knowledge. We are developing a fully fledged equipment as a service infrastructure for all the machinery and all the medtech equipment of EaaS. Again, the idea is to virtualize and standardize the interoperability. We are developing, rather than embracing, a new OPC-based standard for medical machinery interoperability, and we are developing algos for the probe, which according to FDA regulations now needs to be tested by bioengineers every daily, and this is putting pressure on the sales and support infrastructure of EaaS. So we are using artificial intelligence at the edge to automate the testing of probes, but also other parts like digital boards or other information inside the ultrasound and MRI machinery. Last but not least, the final project is the Satisfaction project, which is done for the European Space Agency, using satellites to actually track containers and reefers in the food supply chain, which has been quite mission critical during COVID, with a lot of machinery stopped into Chinese and Asiatic ports or other ports around and harbors around the world, with the containers continuously detached from the electric plug. So the idea is actually to monitor worldwide all the containers and get them continuously monitored and tracked in terms of where they are, using innovative sat-nav applications like the Galileo increased tracking functionality, and merging it also with satellite uplink communication, where the cargo and moving equipment happens to be in the middle of nowhere, typically in the ocean or in the middle of very wild spaces. Last but not least, we are also embedding satellite Earth observation in order to do image-based analysis if where the equipment is stolen or eventually subject to meteorological harsher conditions like floods or fires and so on. It's automatically detected by the MYWAI platform using intelligence, edge intelligence or cloud intelligence on Earth observation, meshed up with data fusion coming from the sensors included inside this specific device here, that we are seeing, which is attached to containers. And it's actually this piece of equipment which is actually attached to the containers. We also attach it to the fence and to other containers, and that's why we have different forges. These are the sensors that we are actually attaching to the machines also for vibrational analysis. And last but not least, this is the very interesting M2 board, which has got more than 4,500 neurons for classification, which can be slotted inside existing edge computers like this industrial Raspberry, or third-party solutions from Advantech and others, as I was saying before. So if you want to actually see all this, you can actually come to visit us in our offices, in our R&D labs in Sesse Levante, Northwest Italian Riviera. You can go to our website by looking at the QR code here in your mobile, or if you are happening to visit the Cannes event, you can come to our booth in Cannes in the world's first AI conference setting up where we are exhibiting next time in Cannes. Okay, so thank you everybody, and see you soon.